morning, everyone. Good morning, everyone.
Good morning.
Thank you. So today we want to begin a topic called correlation and regression. Now, there's a slight difference between the two, but both of them work towards the same goal. In mathematics, or even in real life, because the essence of studying mathematics is to be able to solve real-life problems. Okay? We might have a situation whereby you have bivariate data. When I say bivariate data, I mean a data involving two variables, two quantities. I want to know, is there a relationship between these two information? And if there is, to what degree are they related? Am I making sense? Some of your science, IAs, and whatever will be based on some of this statistical investigation. This is the reason I'm bringing this topic now. Normally, I would teach it with topic 4. Okay? But having learned from the current Form 6, I thought it would be wise for us to do this earlier in Form 5. After correlation and regression, I'm moving back to topic 3. This is the only thing I want to take in topic 4. Am I making sense? So the idea of correlation and regression is to study the relationship between two variables. For example, is there a connection between the hours of study and grade obtained? That might be a question you want to answer. Am I making sense? Then you can talk to your 17 classmates. How much time do you study? You write it down. How much time do you study? You write it down. How much time do you study? You write it down. For maybe a particular test, it could be Mr. Daniel's test. And at the end, you collect the data. What is your percentage score? You write it down. What is your percentage score? You write it down. And then you want to know, is there a connection between the two? Or is it just by chance? Are you with me? You might be doing something in your biology, and you want to know if this particular data A and data B have any relationship whatsoever. And if they have a relationship, you want to know to what degree do these two relationships exist. So you know how to rely on that data, how much reliability you can have. Okay? I remember one of the question type that my teachers or lecturers used to give those days. In my polytechnic days, I had a diploma in statistics right after high school. It's like the IB. We are no longer in high school. So you can do a polytechnic program for 2 years, then you cross to university and you don't have to start from level 1 anymore. You go straight to year 2 if you have a diploma in our system. Or you can go for higher diploma and graduate after another 2 years of higher diploma. So in my ordinary diploma, that's what we call it, ordinary national diploma, we did something on correlation and regression. And I remember one of the questions that my lecturer used to either give us as assignment or in the test is about 3 judges. 3 judges, A, B, and C, who are given rating to some beauty pageant contestants. So we have judge A, B, and C. So for every contestant, maybe contestants 1 to 10, then you have judges A to C, giving them a percentage rank, or maybe just rank them. Oh, I think this contestant is number 1. I think this is number 2. I think this is number 3. Oh, I think these 4 and 5 are tied. So you have 4.5, 4.5, something like that. Or just 4, 4. Then there will be no 5. The next will be 6. Am I making sense? Mm-hmm. So after all these 3 judges, let's say these 3 judges are Yanko, Kaza, and Elsin. So one of the questions we are often asked is, which 2 judges agree most? These are some of the mathematical tools that we normally use those days to check. So that if a winner is to be selected with this calculation, if the calculation made, there is a stronger agreement between these 2 than any other combination of 2 judges, then whatever these 2 say will be the final. Am I making sense? So this is the idea of correlation and regression. Another thing we could use correlation and regression for, just to give you an idea. OU did, maybe we discovered from the previous experiment that mathematics and physics data are related. So maybe the higher you score in maths, the higher you score in physics. And the lower you score in maths, the lower you score in physics. Maybe we have a data that's confirmed there's a relationship between them. Okay? However, today is Wednesday. It came from maths test. But after the whole class, he went to take vaccine and he couldn't come for physics test tomorrow. And there's no other opportunity to write the test. Do you understand that? But then we have to give him a term report. Then we can have a model of the relationship that can best approximate, okay, that can best approximate the relationship between the two, such that we can predict one if we have only one of the other. This is having established, are you with me? We have already established that math and physics are related. Then we can now get the model and say, oh, this straight line actually gives us the model. So if I know 50% in math, I can get maybe 52 in physics. Or if I get, 60 in math, I can get maybe 59 in physics from this model. So if it misses one, we can use that to predict and estimate, not actual, of what it will get, which will be sufficient to do its report for that time. To check if there's a relationship between them, to know, is there a relationship between them? To what degree is that relationship? That is the power of correlation. I'm not there yet. The correlation tells you that. Are they related? To what degree do they relate? What kind of relationship? Correlation establishes that. Regression gives you the exact model of that relationship. Correlation only tells you, oh, there is no relationship between X and Y. Okay? Because the correlation coefficient is 0. But regression will tell you, actually, X and Y are related by X is equal to AY plus B. Do you understand the idea now? This is what we are going to do for the next few lessons, starting today. Okay? Do we understand what I'm trying to do so far?
Yep.
All right? So please ask questions. So the first thing, I'm going to go through with the book, which is easier. Some of these we have heard of in IGCSE days, yes?
Yeah.
Something about correlation, but the only thing we teach you then is the scatter diagram, right?
Yeah.
Oh, draw the scatter diagram, tell us if this is positive or negative correlation, but here we are going deeper, okay, with the first section, and I have a worksheet on that. So the first thing is the association of two variables. This table shows the age of people and how long they can throw something, the distance that you can throw. So someone who is age 10 can throw just 10 meters. Someone who is age 12 can throw 20 meters. There is someone who is age 13 that is also able to throw 20. Age 16 to throw something about 22.5, 23. Someone who is age 20 throws the longest. So we can say, to some extent, that age and distance throw are related. Do you agree with this 100%? And why? Yes, miss.
No, because you can see some of them at the same age, they can throw different height. Like some throw a longer distance, some throw a shorter distance.
Maybe you are not getting the question, or maybe you are thinking about it the other way, but that's a nice attempt. I'm not saying this graph is a wrong graph, because it's actually from a data, okay? My point is, can you conveniently say, because clearly, someone who is age 10, you don't expect them to be that strong to be able to throw compared to someone who's age 18. Someone who's age 10 is probably in P5 right now, right? And someone who's 18 is in that class. It's like comparing Jocelyn with Brandy. So you will expect Brandy to throw longer, right? Because of what factor? Give me some of the factors.
Height.
Of course, the age, the height,
Muscle.
the muscle, thank you, yes.
Male.
Male, well, this is not gender specific. Just even pick Jaslyn and Joey too.
The skill.
The what?
Skill.
Skill. How do you mean skill?
There's a strategy in throwing.
Strategy, yes. You don't expect someone younger to be that mature to think of those strategy, right? Maybe you have learned something about physics, you know, or you have to stand at a point, or you have to apply something. You can think about all that. They just want to throw. They don't think about all that, right? Then also the muscle, like someone said. You don't expect, what? Arm length as well. So many factors, right? But can you tell me the limitation of this model? Anyone? Yes, sir.
So, like, isn't partly of the age. Like,
Say that again?
Isn't part of the age.
It's on the part of the age. Okay, so what's the limitation?
So it's not complete. So you can't predict an entire statement based on part of the data.
You can't predict based on part of the age. I give you that. Any other one? Because from the look of things, we can actually have a line of best fit. We're not going to talk about that in a minute, right? And can predict that someone who is age X is likely to throw. You remember, likely. Okay, likely. That is the reason someone who is 13 can throw higher than someone who is even 15. So it's possible. We have some people that are very skilled. Okay? And they come and be in Form 5. She plays badminton better than maybe teachers in the staff room. Not even maybe. That's a fact. So it's not a function of the age in that regard. Because of a skill. So we have peculiar cases. But there is something I want you to visualize here. Or something I want you to think about. If I draw a line, can that line predict every age correctly, and why? Yes.
I would say no.
Okay.
Because if you're drawing a line of best fit and it keeps going up, you don't expect someone who's 110 years old to be able to throw about 200 meters.
Can you give him a round of applause? Very nice. Because again, remember, this age of a thing, you are weak when you're young, you are strong when you are like this, and then you are weak again when you're older. So if you draw the line of best fit, are you saying my great-grandmother can throw longer than I can throw? I mean, like,
Possibly.
really?
You're underestimating the person.
Do you understand that? You're like, oh, grandma, don't even embarrass yourself because I can throw longer than you can. So we see that while we can have that, there will be some limitation. Okay? So I just want us to understand the association between two variables with this conversation. Now, what is correlation? Like I said, it refers to that association, the relationship between two variables. When there's a relationship, you can say, oh, they are correlated. Or there is a correlation between them. What type of correlation? We'll talk about that in a bit. Understand?
Mm-hmm.
Take hours spent on social media and
Popularity.
may I please?
Okay.
Hours spent on social media and performance in school, for example. Or even performance at work. If every time I leave work, from go to Facebook, I go to Twitter, I go to YouTube, I go to Snapchat, I do that all day. As long as I'm not in your class, I'm on social media. Do you think I will be able to perform as much as I will if I limit my social media presence? Can you see? So we can see that the lesser time on social media I spend on social media, the more time I can prepare for the class, and the better I can deliver as a teacher. Yes or no?
Yes.
So we can have a line that will be negative.
Mm-hmm.
Less time, higher performance. More time, lower performance. The gradient is negative, isn't it? And that's a negative correlation. Okay? Maybe not exactly, but the more time you can spend with your work, the better you can perform at that. Maybe not everybody will agree 100% because of certain factors. Of course, we have factors that may lead to otherwise. But you can say that these two variables are related, so there's a correlation between them. If they are not related, then there's no correlation. It's like age and your bank balance. There's no correlation between them. Because I'm sure there is at least one person here who probably have a multiple of what I have in my bank balance right now. So it's not a function of age. Somewhere, a prince has just been born that could probably buy the entire building, even though he or she doesn't know anything about money yet. But their net worth already can buy the whole building. Do you understand that? And we have someone who is way old, and even the poorest can afford, the poorest maybe in this environment, can afford to feed them conveniently for a year. So in that case, when someone says, is age and net worth related? The answer is no. There is no correlation. Correlation establishes the association or the relationship between two variables. Okay? Now, there are some characteristics that can further tell us what kind of correlation we are dealing with. One of them is the direction here. This, from your IGCSE, is called what? What type of correlation?
Positive.
And this is what?
Negative.
And this is?
No correlation.
So this is from your IGCSE. So that is one characteristic, direction. The direction of the pattern can tell you what type of correlation you are dealing with. There's another characteristic here. Linearity. Of course, for this level, you are only going to deal with linear correlation. You are not dealing with non-linear. Okay? So linearity, which is why we can only talk about line of best fit, line, not a curve, for this level. If someone is going to explore advanced statistics later, you might get something that is, beyond. But for IB, HL, SL, linear. So your correlation is linear if you have that trend compared to the other one. If everything is approximately on a straight line. Remember, approximately, not exactly. The strengths. How strong is that relationship? Because the strength of that relationship can then tell you how trustworthy your prediction is, how reliable the prediction is. Okay? We can have strong, moderate, and weak. Both positive and negative. Okay? There is a range of values where you can, because there's something called correlation coefficient, there's a range of values. Okay, before then, let's talk about outlier. In statistics, an outlier is that particular data, just like outcomes, you're stepping on your mouse right now. There's a particular data that is far away from every other data, either too small or too large. I'll give you an example. My age will be an outlier in this classroom. If you take the age distribution of this room right now, then mine will be the outlier. Because your ages will cluster within a particular neighborhood, while mine will be far away. Okay? Or if someone of, say, P3 age comes into this class, then that's another outlier. Because it's far away from every other one. So an outlier is that particular data. Okay? It's the isolated point which does not follow the trend formed by the main body of the data, as you can see here. Everyone is here. What is he doing here? Oh, I don't want to talk to people. Oh, yeah, that's an outlier.
So yeah, it's not that
I'm sorry.
It does the wrong way.
This is still within the trend, I'm sorry. This is still within the trend. Okay, but in the normal data, The one far away. This is because we are talking about a particular trend, line of best fit. Sorry about that. This is the one. It's not within the trend. In your normal data, like the age I was talking about, someone who is way older is the outlier, gives us the outlier data. And the effect of that you will learn in topic 4. It's an interesting idea in topic 4. Okay? Now, the last thing I want us to, because this is just like introduction, so there's no, I just want you to listen to this explanation. Now, this is exactly what we talked about, and the answer he talked about. The fact that there's a correlation between the two does not mean that one variable actually causes the other. Okay? Now let's look at this. The arm length and running speed of a sample of young children were measured, and a strong positive correlation was found. We also talked about it, arm length, right? Somebody said, was it Kelly? Yeah. When you throw. So there's a correlation between that. If someone has a very short arm length, they're probably going to throw short stuff, right? If someone has a very long one, of course you expect them to throw longer than everybody. Even Usain Bolt has a very strong long leg, right? Even though the guy pretended to be jogging while everybody's running with all their strength, and he still wins. Anyway, now this does not mean short arm causes a reduction in running speed. Okay, or maybe higher one will give you that. Rather, there is a strong positive correlation between the variables because arm length and running speed are closely related to a third variable, which is age. So it wasn't the arm length directly that causes that speed, but the speed and the arm length converge somewhere. The age of the person running. And of course, with age comes a better development of the body system, of the brain. Someone is talking about, was it skill you mentioned the other time? Someone's talking about skill. That has nothing to do with arm length. That has to do with strategy. Strategy comes with the age. Okay, how can I win this race? Okay, maybe before I get that thing from my partner, maybe I run and I just jog so that I can keep the momentum running. What do they know about momentum at age 2? Some of them will probably wait, get the baton and start running. If they don't even run in the opposite direction and lose. Do you understand that? So that is what this is talking about. Again, look at this. I want to run through this specific example because it's so trivial. The number of television sets sold in London and the number of stray dogs collected in Boston were recorded over the years. A positive correlation was found between the two variables. What has television sold got to do with stray dogs? Even though when the data was put on the scatter plot and when the correlation coefficient was found, it is positive. But does it mean that the stray dog causes the television to be sold in a higher number? Or does it mean that lower sets, lower number of television sold gives lower number of stray dogs on the street? No. That's what this is talking about. Okay? Obviously, the number of television sets sold in London was not influencing the number of stray dogs, blah, blah, blah. So this is what this is talking about. Now, this is where we're going. If a change in one variable causes the change in the other variable, then you can say there's a causal relationship. One causes the other. I've given an example today. Can someone remind me? One variable that I mentioned today that can cause a change in the other variable. In few examples that I've given today, we have already talked about a causal relationship today.
Amount of time studied.
Speak louder, sir.
The amount of time studied and the grade.
The number of time studied and the grade. That we can agree with to some extent. Even though some people are so smart they don't even study. While some of us will study for 10 hours and they still get more than we get. But at least we can all agree that because from the idea of practice makes perfection, if you do not practice well, you may not perform as much as someone who devotes more time practicing. Do you understand that? If I start playing badminton today, and I devote less time, I will just keep looking at Anika up there because she spends so much time practicing. And that makes her better and better all the time. So there's a causal relationship between the hours that she spent practicing and the performance recorded. Does that make sense? Bless you, ma'am. Now, for the purpose of this class, you might be seeing explanatory variable and response variable. In another material, maybe you look at some material online or whatever, you might be seeing dependent and independent variable. I will explain more about that in a bit. Everybody, look here, please. Your x and y, from your line y is equal to mx plus c. You could see that when you substitute x, you can get your y, isn't it? Hello?
Yes.
So which means y depends on x. Am I right?
Yes.
Y takes its value based on whatever x brings. In that case, we can say y is the dependent variable, the guy that depends on every other person. Dependent variable. Yx is the what? Independent variable. In your IB exam, most times your table is arranged X, Y format. But then I want you to look at the information and check yourself. Is X the independent one? Is the other one the one depending on the one at the top? Because we're going to get to a point where you need to distinguish. But for your exam, I think it's always label X, Y automatically. So you're lucky. If I have a lecturer that is very tricky and tough, Mr. Shojobi, we often, sometimes, we have to be the one to differentiate. Sometimes we will flip the table. So you have to be able to know, okay, he puts Y first instead of X first. Okay, but if you understand this idea, you will be fine. And that is the idea of explanatory variable and response variable. Okay? Now, we can say that independent variable explains the dependent variable. Is that not? This is your dependent variable, this is your independent variable. It explains the dependent variable. It tells us, it brings out the value of y. Okay? Now, quickly, we're going to answer a few questions together. For each of these, describe the relationship between the two variables. Tell us about the direction, linearity, and strength of the relationship. If there's any outlier, tell us. Number A, who wants to begin? Yes, sir.
It's a positive correlation.
Do we all agree with that?
Yes.
Is it moderate, strong, or weak?
It's moderate.
Moderate. Do we agree with that?
Yes.
Is it linear?
Yes.
We have to talk about linearity too.
Yeah. No, it's linear.
It's a linear, positive.
It's a linear, positive, moderate correlation.
Yeah, it doesn't matter the way you arrange it, but just put it in a, you can say it's a linear, positive correlation, or it's a linear, I think moderate should come before positive, but it doesn't matter.
Linear, moderate, positive correlation. With
Can we
no
see any outlier here?
No.
No. What about B? Who wants to go for B? Carolina?
It's a linear negative correlation, and it's strong, and
It's strong.
it has one outlier.
That's one outlier. Do we all agree with that?
Yes.
Who wants to try the next one? King? You want to try? Negative. Are you sure? Ada, what do you think?
I don't think there's any correlation.
There's no correlation. Look, it's just scattered around. If you want to draw a line, you can't really fit it. There's no correlation. Nice observation here. King, can you want to try D? What, say that again? D is negative, yes. What's more? There's one outlier. Yes, that's it. Is it moderate? Or is it strong? Or is it weak? Is it even linear?
No, it's not.
This is not linear. It looks like a curve. So that's not a linear, it's a non-linear. Okay, correlation. Okay, non-linear negative correlation with an outlier.
Strong.
And it is strong because they are all the cluster along the paths. Right? Ryan, want to try E?